So it looks like NVIDIA is completely changing the rules of the AI game. You see, the jump from their brand new Blackwell chip to the next generation Rubin architecture, well, it's not just another upgrade. We're talking about a strategic disruption that literally cuts the time between generations in half. So let's break down what this massive acceleration really truly means. And that brings up a really big question, right? Blackwell is an absolute monster of a chip, and it's just now starting to ship. So why in the world is NVIDIA already talking about its successor, Rubin, coming out just next year? I mean, this is not business as usual. It's a huge speed up of their whole product cycle, and it tells you something big is changing in the world of AI. Okay, so here's how we're going to tackle this. First, we'll get into this wild new one-year cadence. Then, we'll set the stage with Blackwell, the current champ. After that, we'll dive into how Rubin is a total reset, what that means for the data centers, the AI factories, and finally, we'll wrap up with the key strategic takeaways you need to know. All right, first things first, the timeline. For years, we all got used to NVIDIA's pretty predictable 2-year refresh cycle. Well, you can throw that out the window. They've shifted gears to this incredibly aggressive 1-year cadence. And the reason? It's simple. The absolutely relentless demand to build AI models with trillions of parameters. And when you look at the calendar, it is just, wow, it's tight. Blackwell systems are literally rolling out now and through the first half of 2025. But look at this. Mass production for Rubin kicks off in late 2025, with big deployments hitting in 2026. The gap between these massive architectural leaps has been sliced in half. It's an unbelievably aggressive schedule. Okay, so before we can really grasp how huge of a leap Rubin is, we have to talk about the current king of the hill, Blackwell. And this isn't some old chip on its way out. No way. This is the brand new foundation for today's generative AI. It's the performance baseline that Rubin is about to absolutely shatter. And believe me, this is one heck of a baseline. Blackwell is built on a custom 4-nanometer process packing a staggering 208 billion transistors. It's got 192 gigs of super-fast HBM3E memory, and it's already a power-hungry beast, pulling 1,000 watts for its main server module. These are just monster specs by any standard. But out of all those specs, there's one number you really need to lock in your brain: 15 petaflops. That's the peak performance of the top-of-the-line Blackwell chip using this specialized 4-bit format called FP4. Now, this format has become the key metric for AI inference, and 15 petaflops, that is a ridiculous amount of power. So remember that number, 15. All right, now let's talk Rubin. And let me be super clear, this is not Blackwell 2.0. The source material calls it a foundational reset, and man, they are not kidding. We're talking a complete top-to-bottom overhaul of the entire technology stack. Which, makes you wonder, if Blackwell is already so powerful, how on earth is NVIDIA pulling off this kind of massive generational leap in just a single year? Well, the answer isn't one little trick, it's a revolution across the entire platform. It really comes down to 4 fundamental shifts, 4 big moves they're making all at once. Rubin jumps to a more advanced 3-nanometer process so you can cram more stuff in. It moves to a new multi-chiplet design, which lets them build more powerful processors. It upgrades to next-gen HBM4 memory for way more bandwidth. And it gets a brand new CPU partner, called Vera, to feed that GPU beast. Any one of these would be a big deal on its own. And when you put all that new tech together, what do you get? Well, remember Blackwell's 15 petaflops? Get ready for this. The flagship Rubin R100 is projected to deliver a mind-blowing 50 petaflops of FP4 performance. 50! That is just a monumental leap in raw power. I mean, just look at this. Visually, it's not even a fair fight. Rubin doesn't just inch past its predecessor, it completely towers over it. We are talking about a totally different class of performance here. Yeah, let's just put that in simple terms. We're talking a 3.3 to 5 times increase in AI inference throughput over the chip it's replacing. That kind of jump isn't just an improvement. It's the kind of thing that opens up entirely new possibilities for what AI can do. And it's not just about the raw horsepower. This jump to HBM4 memory is so critical. Think of it like getting the AI model a much, much bigger and faster short-term memory to play with. Rubin gets 50% more of it, a whopping 288 gigabytes and nearly double the speed. This is absolutely essential for dealing with those giant next-gen language models. Okay, but all this incredible power, it comes with a catch. A chip this powerful has huge implications for the data centers, the AI factories that have to house them. And this, right here, is where the real challenge starts to kick in. And this right here is the number that should make every data center operator a little nervous. Over 150 kilowatts. That's what they're expecting to be the power density needed for just a single rack of Rubin systems. To put that in perspective, that is an insane amount of power and heat all crammed into a tiny space, way beyond what most data centers today are built to handle. So what does that actually mean? Well, the ripple effect is profound. Forget about traditional air cooling. For these systems, it's basically obsolete. Liquid cooling? It's not a fancy option anymore. It's a mandatory, must-have piece of infrastructure. And this all leads to a really interesting conclusion. The new bottleneck for AI isn't going to be getting the chips. It's going to be having data centers physically ready to power and cool them. So you might be thinking, how does anyone afford this? Well, NVIDIA has a pretty clever answer, a strategic split. Alongside that beastly R100, they're launching the Rubin CPX. It's a more specialized chip that uses cheaper, less power-hungry memory. The whole idea is to give you two tools for the job, the max performance R100 for the really heavy-duty training, and the more cost-effective CPX for when you need to scale out inference to millions of users. And then, when you zoom out and look at the whole system, the numbers just get, well, they get ridiculous. The top-tier Blackwell system links up 72 GPUs for around 3.3 exaflops of performance. The biggest Rubin system, it connects 576 GPUs, pushing performance to almost 15 exaflops. It's just a whole new scale of computing. Okay, so let's boil all this down. What does this actually mean for you, for anyone building, investing, or just relying on AI? Let's get into the key strategic takeaways for the next couple of years. The analysis really points to three super clear actions. First, think of Blackwell as a tactical buy. Get what you need for today, but make your long-term plans around the massive leap that's coming with Rubin. Second, start overhauling your infrastructure now. Budgeting for liquid cooling isn't a maybe anymore. And third, plan on using both chips, the R100 for training and that cost-effective CPX for inference at scale. And all of this leaves us with one big lingering question, doesn't it? With NVIDIA on this relentless one-year cycle, pushing performance to such extremes, are we heading into a new era? An era where the next big breakthroughs in AI aren't limited by clever code, but by the raw physical limits of our data centers, power, cooling, and just plain space. Definitely something to think about. Thanks for tuning in.